In this video, we will solve a problem on competitive equilibrium in exchange economy. The question is, there are two goods X and Y and there are two consumers A and B in a pure exchange economy. Consumer A and B have the Cobb-Douglas utility function that is being given us. The utility function of person A is 2x raised power 0.4 times y raised power 0.6, and utility function of consumer B is x raised power 0.3 times y raised power 0.7 respectively. Initially, consumer A is endowed with 50 units of good X and 20 units of good Y. Similarly, consumer B is endowed with 50 units of good X and 20 units of good Y. If the unit price of good Y is normalized to unity, that is equal to 1, then the equilibrium unit price of good X is we need to find out. Okay, so this is actually a pure exchange economy question. So what we are being given here, we are being given the utility function of person A is being given by, that is twice x raised power 0.3, and let's write here the subscript A denoting for the consumer A, times y raised power 0.7 A. This is the utility function of consumer A. Similarly, we are being given the utility function of consumer B, that is utility function of consumer B is being given us as x raised power 0.3. Let's write the subscript here, okay, for consumer B, times y raised power 0.7 subscript B. These are the utility functions of two consumers. Okay, also we are being told that consumer A is endowed with 50 units of good X. Okay, let's write the endowment of person A. Okay, what he is endowed with. So let's denote it by W subscript X. That means endowment of good X of consumer A, comma, endowment of good Y by consumer A. And here you can see what is the endowment of we are being given. A is endowed with 50 units of good X, so we have 50 units of good X and 20 units of good Y. Okay, so this is the endowment bundle of person A. Similarly, the endowment bundle of consumer B is, let's denote it by WBX. That means units of good X endowed by person B, comma, WBY, the units of good Y endowed by person B. And here we are also being told that B is endowed with 50 units of good X and 20 units of good Y. So let's write it here again. We have 50 units and 20 units of good Y endowed by person B. Okay, now how do we solve this question? Let us first find out the total income of the consumer. Okay, so let me use another color. Okay, what will be the income of the consumer A? Let's write it here. So income of consumer A will be equal to, that will be equal to the price of price of good X times units of good X endowed by person A, plus price of good Y times units of good Y endowed by person A. Okay, this will be the income of the consumer. Here we are assuming that the consumer has no outside income. The endowment actually are his income here. Okay, so what is the price? And we are also being told that price of Y is being normalized to 1. Okay, so can I write the income of consumer A will be equal to, so endowment of good X by A is being given as 50. So in place of WAX I can write 50 times price of X plus endowment of good Y by person A is 20, and price of Y is 1. We know 1 into 20 will be equal to 20. This will be the income for consumer A. Similarly, we need to find out what will be the income for consumer B. Let's denote it by, and let's write it here. So let us say income of consumer B will be equal to, that will be equal to price of X times units of X endowed by person B plus price of Y times units of good Y endowed by person B. So income of person B will be equal to, price of X is not given, so endowment of X is being given by person B as 50, so we write here 50 PX plus price of Y is assumed or normalized to 1, so it is 1, and endowment of good Y by person B is 20 here. Okay, I'm just trying to show you how to calculate the competitive equilibrium. Okay, so first step is we write the given utility functions and also the initial endowment of the two persons. Next thing is what we do, we find the income of the consumer, that is how do we calculate it. Now next thing is we need to find out the total supply of good X in this economy. Okay, so total supply of good X. What will be the total supply of good X in this economy? And here you can see that will be the endowment of good X and Y held by consumer A and B. Okay, so total supply will be equal to of good X will be equal to the endowment of person A of good X plus the endowment of good X held by person B. That will be equal to WAX plus WBX. Okay, what is WAX? It is 50 plus what is WBX? That is 50 again. So total supply of good X in this economy is equal to 100. Okay, next thing is we need to find out the demand. Okay, gross demand for good X. And what will be the demand for good X? Demand for good X in this economy. Oh, and what will be the demand for good X? Simply that will be the demand of good X. Okay, that will be, and let's write it. So X will be equal to, how do I write it? So total demand for good X will be equal to demand of good X by consumer A plus the demand of good X by consumer B. This will be the total demand in this economy. Okay, so we need to find out this demand function for good X and demand function for good X by consumer A and demand function for good X by consumer B. So we have to calculate these two demand functions first. And how do we calculate the demand functions? You know it pretty well, and let me try to make myself clear here. Okay, so we want to maximize. Okay, I will rub this then. Okay, so let us write the demand function of good X by person A. For that, what will we do? We will maximize the utility function of person A, that is equal to twice X A raised power 0.3 times YA raised power 0.7. Okay, so we have to derive the demand functions of person A and B here subject to the budget. And what will be the budget of the consumer here? For person A, it will be equal to price of X times units of X plus price of Y times units of Y, and here we have XA. Okay, sorry, YA, and it should be equal to the income of the consumer, that is M subscript A. We want to maximize this utility function subject to this budget constraint to derive the demand function for good X by consumer A. So using the tangency condition, we know that at optimality what happens, that is marginal rate of substitution should be equal to the ratio of the prices, that is price of x upon price of y, which implies MRS is simply marginal utility of x upon marginal utility of good y, and it should be equal to price of x upon price of y. MUX means the partial derivative of utility function with respect to good x, and similarly the marginal utility of good y means the partial derivative of utility function with respect to good y, and it should be equal to price of x upon price of y. Okay, now the derivative of this function with respect to x, what will be, and let's write it here y properly. So derivative of this function with respect to xa, and let's write the subscript also here. The derivative of this function with respect to x. Okay, so here we have xa raised power 0.3, so 0.3 will become coefficient, and what is 0.3? 0.3 is actually 3 upon 10. Okay, so I can write it, we have twice into 3 upon 10 xa, and exponent is subtracted by 1, so 0.3 minus 1 is minus 0.7. Ya will remain same because we are taking partials, 0.7 divided by dua upon dya. Now this time we take the derivative with respect to y. Okay, so we have twice here again. 0.7 will become coefficient and it will become 7 upon 10. Okay, times x raised power, xa 0.3, ya, the exponent of y will be subtracted by 1.7 minus 1 is minus 0.3. It should be equal to the ratio of the prices, price of x upon price of y. Okay, here we can do some cancellation. 2 and 2 will get cancelled, so we have 3 upon 10 upon 7 upon 10, so 10 also gets cancelled. We are left with 3 upon 7. Okay, if I transpose ya to numerator, it will get multiplied with this ya. Okay, let me explain it here, it will make more sense. So we have here, if I transpose this, and so we have ya 0.7 in the numerator. If I transpose this ya, it will get multiplied, but exponent sign will change, it will become 0.3. Bases are same, ya 0.7 plus 0.3 comes out to be 1, so we will only get ya in the numerator. And by the same logic, we transpose this xa to denominator, exponent sign will get changed, it will get multiplied with this x raised power 0.3, and it will add up to 1. Okay, so we will get only xa here is equal to price of x upon price of y. So let us solve it for ya here first. So ya will be equal to, that will be equal to price of x. First to transpose this 7 upon 3. Okay, then if I transpose, it will become 7 upon 3. Then we have price of x upon price of y, and transposing this xa. Okay, next what will we do? We plug this value of ya is equal to this stuff into the budget constraint. Okay, so here we put the value of ya. So what will we get? Let me see if I have space left. Yes, I have the space left. So we will get, I will rub this out obviously because I don't have the space. So we have price of x times units of x a plus price of y times y. In place of ya, we write this stuff, that is 7 upon 3 price of x upon price of y times xa, and it should be equal to the income of the consumer A. Here ya gets cancelled, so we are left with price of x times xa plus 7 price of x into xa divided by 3 should be equal to ma. Okay, so doing cross multiplication, so 3px into xa plus 7px into xa, since these are the same terms, like terms, we can add them up. So this becomes 7, 3 plus 7, it comes out to be 10. So we will get, here we will get 10 upon 3. So xa will be equal to 10 upon 3. I guess I have done somewhere I have done the mistake in calculating. Rather, let me see, 3 upon 7, 7 upon 10. So we have so what was, okay, I have done a horrendous mistake here. Now I know why it's getting, here it is 0.4, I have written 0.3. we have to solve for consumer A here first. Sorry, okay, no problem. So here let us suppose then I have to change all the subscripts here. Okay, because the utility function for good person A was this, and I have written this very stuff, so I have to do it again. Okay, sorry for this mistake. So you can see what happens if mistake happens. So demand function for good A, if we want to calculate, so we want to maximize the utility function. Okay, so to calculate the demand function for good A, we want to maximize the utility function of good A, which is being given as twice x raised power 0.4 y raised power 0.6 subject to the budget. What will be the budget? Price of x times units of good x A plus price of y times units of good y held by, rather, of person A should be equal to the income of the consumer A. Okay, now we know the first order condition, rather, for optimality requires that we equate the marginal rate of substitution of good x and y, and it should be equal to price of x upon price of y. MRS means the marginal utility of good x upon marginal utility of good y should be equal to price of x upon price of y. Okay, now to calculate the marginal utility of good x, that means the partial derivative of utility function with respect to good x. Okay, and similarly marginal utility of good y means the partial derivative of utility function with respect to good y, and it should be equal to the ratio of the prices, price of x upon price of y here, which implies what is du upon dxa, that is the derivative of this function with respect to xa. Okay, so here you can see we have the derivative of x raised power 0.4 is 0.4 will become coefficient, so 0.4 can be written as 4 upon 10, which becomes 2 upon 5. Okay, so I can write 2 upon 5 here. Then x raised power, and exponent is subtracted by 1, 0.4 minus 1 is minus 0.6, then we have y raised power 0.6, and similarly du upon dya means the partial derivative of this function, and let's write here a and here also a. Okay, the derivative of this function with respect to ya. Again, since we are taking partials with respect to a, so first we have 2, the exponent is 0.6 will become coefficient, 0.6 is equal to 6 upon 10, which is equal to 3 upon 5. Okay, so we have here 3 upon 5, 3 upon 5, then okay, we have then xa raised power 0.4 y, let's write here a and a, ya raised power minus 0.4, because subtracting 1 from 0.6 gives us minus 0.4, and it should be equal to price of x upon price of y. Okay, here we can do some cancellation. This gets cancelled, 5 and 5 gets cancelled, so we are left with 2 upon 3. So 2 upon 3, if I solve this, and you can see if I transpose ya to numerator, what will happen? So we have ya in the numerator as 0.6. If I transpose this ya, it will get multiplied with this ya, but exponent sign will change. If it is minus 0.5, it will become plus 0. Or rather, if it is minus 0.4, it will become plus 0.4. Bases are same, we can add up the exponents. 0.6 plus 0.4 sums up to 1. So we are left with ya only in the numerator. And similarly, if I transpose this term to denominator, exponent sign will change and it will get multiplied with this xa raised power 0.4, and they will sum up to so rather the exponent will sum up to 1 and we will only get xa. Okay, and it should be equal to price of x upon price of y. Solving for ya, that means ya will be equal to, transposing this, it will become 3 upon 2. Okay, if it is 2 upon 3, it will become 3 upon 2. Then we have price of x upon price of y. Transposing this xa here. Now what will we do? We simply plug the value of ya into the budget function. Okay, so to find out the demand for good A, so price of x into xa plus price of y, and in place of ya we have this 3 upon 2 price of x upon price of y into xa should be equal to the income of the consumer. Okay, here we can do some cancellation. Y and y gets cancelled. Px into xa, px into xa, they are the same term, so we can, this is okay, let me write it properly. Price of x into units of x. Okay, plus then we have 3 px into x divided by 2 is equal to income of person A. Doing cross multiplication, since they are the like terms, we can add them up. So this is 2 px into xa plus 3 px into xa. It sums out to be 5 p x into xa upon 2 is equal to ma. That is the income of the consumer. Okay, I have the space, let me write it here. That means xa will be equal to, that will be equal to, xa will be equal to, so 5 upon 2 will become 2 upon 5. Then we have ma divided by px. Okay, this is the demand function for good x. Okay, itna lamba naam. So demand for good x we calculated as this very stuff, that is equal to 2 upon 5 income of the consumer A upon the price of x. Okay, plus we have to find out the demand function for good B. Okay, for that what we need to do, we need to, and similarly you can see, if we want, since we are interested in equating by competitive equilibrium, what we mean at equilibrium, demand for good x should be equal to supply of good x. We are not solving for good y for the obvious reason, because we only need to find out the equilibrium price, and it will be enough to solve for one market here. Okay, so in the same manner we need to calculate the demand for good x by consumer B. For that what will we do? We take the utility function of the consumer B, that is we want to maximize the utility function of I will not explain it, I will do it a bit fast here. Okay, maximize utility function of person B, which is x raised power 0.3 times y raised power 0.7, such that price of x into units of x plus price of y times units of y by person B should be equal to the income of the person B. Okay, so tangency condition requires M or S should be equal to price of x upon price of y, which implies mux upon muy is equal to price of x upon price of y. Mux means the partial derivative of utility function with respect to good x, and du means du upon dxy means the marginal utility of good y. It should be equal to price of x upon price of y. Du upon dxa means the partial derivative of this function with respect to x here. Okay, so 0.3 can be written as 3 upon 10 here. So in place of the exponent of x becomes coefficient, so we have 3 upon 10. exponent is subtracted by 1.3 minus 1 is minus 0.7, y raised power 0.7 divided by du upon dxb means the derivative of this function. Let's write it here, b and b of this function with respect to b. Okay, so the exponent of y will become coefficient, so 0.7 can be written as 7 upon 10. xb will remain same as 0.3 because we are taking partials. yb 0.7 minus 1 is minus 0.3 should be equal to price of x upon price of y. Here also 10 gets cancelled. Transposing numerators and denominators, we will get 3 upon 7 yb upon xb will be equal to price of x upon price of y. Okay, let's write it here, b and b. Solving for yb, it implies yb will be equal to it will become 7 upon 3. Okay, then we have price of x upon price of y. We have xb here, that gives us. Okay, now we plug the value of yb here. Sorry, here it is y. Okay, sorry for this mistake again, it is yb. So doing this, what will we get? Price of x into x plus price of y. So yb is equal to 7 upon 3 price of x upon price of y into xb should be equal to the income of the consumer b. So y and y gets cancelled. Again, these are the same terms, so 3 times px, or let's write it here, so 3 px into xb plus 7 px into xb upon 3 is equal to income of the consumer. Doing cross multiplication here. Okay, so there is no 3 here. Okay, so it becomes 3 px, or let's write 3 px into xb plus 7 px into xb divided by 3 is equal to mb. Okay, and let me rub this now. So this is 10, they are the like terms, px into xb divided by 3 is equal to mb. Solving for xb, so xb will be equal to, so xb will be equal to, so 10 upon 3 will become 3 upon 10, and px will go to the denominator. Okay, and here we have also mb. Okay, I hope I have done it correctly. So what we got 3 upon 10. Okay, mb upon px. Okay, so what is the demand function for good x by consumer b? That will be equal to 3 mb upon 10 px. Okay, now I can rub this out. Now we know that at equilibrium, demand for good x should be equal to supply of good x. Okay, what is the demand for good x? We have calculated it here, you can see, or let's write it here now. I have now the space. So demand for good x is this, 2 upon 5 ma upon px plus 3 mb upon 10 px. And what is the total supply of good x? That is 100. We calculated it, or let's write it in this fashion, wax, or let's cut it short here. So this is here 100. Okay, 100. This denotes the supply, this denotes the demand. Here again we have the same denominator, we can add up the numerator. So we have twice MA plus 3MB divided by 5. We don't have the same denominator here, sorry. Okay, so first let's make the denominator same. For making denominator same, multiplying this term by 2, the numerator and denominator, so it will become 10 here. Okay, 10px 10px, then the denominator is same. So we have, now we can add up the numerator. So this becomes 4 ma plus 3mb upon 10px is equal to 100. Now we know that the income of consumer A, we calculated it as 50, so we can write 4 in place of MA, we can write 50. Price of X plus 20. Similarly for consumer B, we have 50 price of X plus 20 divided by 10px is equal to 100. Okay, doing the calculation here, let me see if I can do it correctly. So this is 4 5s are 20, so this is 200. Price of X plus 4 2s are 80 plus 3 5s are 150. Price of X plus 3 2s are 60 divided by 10px is equal to 100. That gives us, so 200 plus 200 plus 150, X comes out to be 350 price of X. So this sums up to be 140. Okay, 80 plus 60 upon 10px 100. Okay. So it will become 350 price of X plus 140 is equal to 100 into 10 is 1000 price of X. So transposing this, 1000 price of X minus 350 price of X is equal to 140. So now issue 1000 اَتھ والو 350 0 0 5 5. Okay, in the yemis in the yemis I he 10 5 5 in the yemis banya 9 3 6. So this is 650. 650 price of X is equal to 140, or price of X will be equal to 140 upon 650. So this gets cancelled, so price of X will be equal to 14 upon 65. Okay, so this will be the price for good X year. I hope I make myself clear in this video. Thank you.